What happens when you bet $500 billion on a single building? Deep in the Texas desert, where oil derricks once dotted the horizon, a different kind of extraction is taking place. The STARGATE project, a collaboration between OpenAI and Oracle, represents the largest single infrastructure investment in American history. 10 gigawatts of power, $500 billion. A data center complex so massive it will consume more electricity than entire countries. And according to industry insiders, the first phase is already operational. The story begins with power planning on a scale that defies comprehension. Engineers started with a fundamental question: how do you deliver 10 gigawatts of continuous electricity to a single location? That's enough power to run New York City's residential grid. The answer required reimagining America's electrical infrastructure itself. 3 dedicated nuclear reactors are being constructed specifically for STARGATE, each generating over 3 gigawatts. But nuclear takes years, so the immediate solution involves a web of high-voltage transmission lines stretching across 4 states, drawing power from wind farms, natural gas plants, and solar installations across the Southwest. The electrical substations alone cover 60 acres, housing transformers the size of suburban homes. Each transformer weighs 400 tons and had to be transported on specialized rail cars, requiring the temporary removal of highway overpasses along the route. Moving just one required a convoy of escort vehicles and took 3 days to travel 200 miles. With power secured, the concrete phase began. The main structure spans 12 million square feet. Imagine Pentagon-sized buildings connected in a grid pattern stretching to the horizon. But this isn't ordinary concrete. The foundation alone required 800,000 cubic yards of specialized mix, embedded with cooling channels and fiber optic conduits. Every pour had to be completed within 6-hour windows to prevent thermal cracking. The walls incorporate lead-lined sections for electromagnetic shielding and blast-resistant panels designed to withstand Category 5 hurricanes. Construction crews worked in 12-hour shifts, 7 days a week, pouring concrete continuously for 18 months. The logistics meant maintaining a fleet of 600 concrete mixer trucks in constant rotation, one truck arriving every 30 seconds during peak construction. The electrical infrastructure inside STARGATE pushes beyond anything previously attempted in commercial construction. Over 40,000 miles of power cables snake through the facility, enough copper to wrap around Earth's equator twice. The main electrical substations feed into 16,000 individual power distribution units, each capable of delivering precise voltage to server racks, while monitoring power quality millisecond by millisecond. Redundancy is built into every level. Triple backup transformers, isolated power grids, and emergency battery banks containing enough lithium-ion cells to power downtown Dallas for 6 hours. The switching gear alone cost $2 billion and required specialized installation teams trained in ultra-high voltage systems normally reserved for power plant construction. Cooling 10 gigawatts of processing power creates a thermal management challenge that borders on the impossible. Traditional air conditioning would consume nearly as much power as the servers themselves. Instead, STARGATE employs a hybrid approach, combining liquid cooling, immersion tanks, and atmospheric heat rejection. 24 cooling towers, each standing 12 stories tall, dominate the facility's skyline. Inside, specially designed server racks are submerged in dielectric coolant, a synthetic fluid that doesn't conduct electricity but absorbs heat 5 times more effectively than air. The coolant circulates through a closed-loop system, featuring pumps capable of moving 40,000 gallons per minute. When outside temperatures exceed design limits, the facility can tap into underground aquifers through wells drilled 800 feet deep, though environmental permits restrict this to emergency conditions only. Even so, the facility's cooling system moves enough water daily to supply a city of 100,000 people. Server and GPU deployment at STARGATE operates like a precision military operation. Each server rack contains 400 specialized chips designed specifically for artificial intelligence workloads, consuming 40 kilowatts of power, enough to run 40 average American homes. Installation crews work in cleanroom conditions, handling components worth millions of dollars per rack. The GPUs themselves represent the cutting edge of semiconductor manufacturing, chips built on 3-nanometer processes with transistors smaller than viruses. Every component is tested, cataloged, and tracked through blockchain-based inventory systems. Failed components are immediately flagged by monitoring software and replaced within 15 minutes to maintain operational continuity. The facility houses over 2 million individual processing cores, each capable of performing 16 trillion calculations per second. To put that in perspective, the entire facility can perform more calculations in 1 second than every human who ever lived could perform in a lifetime using pencil and paper. Network Interconnect transforms raw computing power into a unified artificial intelligence system. Fiber optic cables carry data between server racks at light speed, but even light has limitations at this scale. Custom-designed switches route traffic through the facility using protocols that prioritize different types of AI training tasks. The external connectivity required laying dedicated fiber lines to major internet exchange points in Dallas, Houston, and Austin. Over 800 miles of underground cable installation. Stargate's internet bandwidth exceeds that of most countries. 400 terabits per second of sustained throughput. That's enough bandwidth to download the entire contents of the Library of Congress in under 3 seconds. Latency between any 2 points in the facility is kept below 50 microseconds, fast enough that the entire facility behaves as a single, coherent computer. The networking hardware alone weighs over 10,000 tons and generates enough heat to warm a small town. Live operations reveal the true audacity of the Stargate project. The facility runs continuously, with human operators monitoring thousands of parameters from a central control room that resembles NASA's mission control. Artificial intelligence systems are already training on datasets so large they cannot be stored on conventional drives. Instead, data streams directly from satellites, and internet feeds in real time. Power consumption varies based on computational load, swinging between 6 and 10 gigawatts throughout the day. During peak operations, the facility consumes more electricity than the entire country of Denmark. The facility's AI models are solving problems in physics, chemistry, and mathematics that were previously beyond human capability. Early results suggest breakthroughs in drug discovery, materials science, and climate modeling. Yet the most significant experiments remain classified, hidden behind layers of security clearance and non-disclosure agreements. What we do know is that the AI systems are being trained on datasets that include real-time feeds from weather satellites, particle accelerators, and astronomical observatories. The implications extend far beyond technology. Stargate represents a new category of infrastructure, not just a building, but a machine for generating intelligence itself. Its processing capability exceeds the combined computing power of the top 500 supercomputers from just 3 years ago. Local communities grapple with the sudden influx of technical workers, while environmentalists debate the carbon footprint of artificial intelligence development. The facility's location was chosen partly for proximity to renewable energy sources, yet its massive power demands strain regional electrical grids. Construction employed over 30,000 workers at peak, creating a temporary boomtown in rural Texas. Local hotels were booked solid for 2 years straight, but as operations become increasingly automated, human presence at the facility continues to shrink. Most operations are now controlled remotely from control centers in California and Washington. The important detail is that 500 billion and 10 gigawatts, Stargate is the largest infrastructure bet in American history. And it's already running is not one machine. It is a chain of physical constraints that must work together. The real sequence is unforgiving. Site power planning, concrete shell, electrical substations, cooling systems, server GPU deployment, network interconnect, live operations, and final verification. But what happens when you give an artificial intelligence system the thinking power of 10 gigawatts and ask it to solve problems?